So all of you in MLflow, if you see what happens is a folder got that is called ML runs is created. And in ML runs, you will find that all the different runs that we are making, it is saving it here. So that is why, and then there is the UI in which we create the MLflow UI in which it shows the results or shows the database which it is creating. So for example, let us rework on this one. So I'm running the data set. So we have run this. We have run the data set. I have created the model. So here, once we have created the model, these steps we discussed yesterday, what we are going to do, we are going to set an experiment. And here, suppose I'll name the experiment some new experiment just for today's session. Like let's name it like 1708 MLOps hard case study. And then we are logging the different parameters of random forest classifier and we are calling it. So if you see the log model random forest classifier, we are logging all three parameters of the classifier. We are logging the model here also and here also. I think we can remove one of them. Then we have model run and then we are printing one run ID. This run ID is what you will see that as soon as a run ID is created, that with that a folder will be created here. So suppose now I run this, it's going to create the model and after as the model is created, it will set up everything in the MLflow. So here it is saying MLflow has been created. This is the run ID. And if you see this folder, you saw that there is one more folder created and that is the run ID. Based on the new run, it creates that ID. So it keeps on creating these folders in order to log everything in your machine. And that is what we are accessing through the MLflow UI. Now, once this is done, we can try to run this MLflow. So this has been created. Can you see a new experiment has been created? MLOps hard case that we just created. The run name is created by default by MLflow itself, so we don't need to worry how much time it took, what is the source, and which model was run. So every detail is logged. If we click on this, it also gives which are the parameters we are logging here and what was the, which are the metrics we are logging here, what was the parameters we are logging here. Everything is being tracked here. What time it was run, where was the source, all those things are run. Not only that, if you look at one more important thing is artifacts. So now what is artifact? This is another keyword which you all have to get used to. So artifacts means when you make a run, when you make a machine learning model run, you get, and if you are saving the model, it creates artifacts. And these artifacts are required to model. So for example, suppose I have trained which model here? So here we are training the random forest classifier. Now, when you have trained the model, suppose this trained model is going to be used in production. Will we use or will we train the model again in production? Yes or no? So the answer to this is no. Currently, you may think that training is very easy. It takes few seconds. The answer is no. Your data set is large, it will take a lot of time and it may change. Every training may have different randomness to it and it may change the results. So we do not train the model when we put it in production. What we do, we use the artifacts or we save the model and that saved model is used in production. Now what format is the trained model saved? So you have a pickle file created, you may have a joblib file created. There are other formats, we call them serialized model, in which other formats it gets saved. So here, when you train the model, we are not saving the model explicitly, but who is saving the model for us? You will see that MLflow is saving the model and it is telling you where it is saving the model. So if you see here, it is creating, the folder I mentioned, ML runs. In that, it has saved the model in this particular folder. 145 here, if you see 1452 in models folder, it has created this where it is saving all the required artifacts, that is pickle file, environment it was used, environment, the requirements of this, everything is saved here. So what version of code was used, what version of MLflow, Cloud Pickle, NumPy, whatever packages was used in this model, everything is getting saved here. So it helps us reproduce this when we want to use it. Now suppose you all decided that this is not doing well, it's not performing well. What we will do, we will go back and suppose I will change the number of estimators from 5 to 2, maximum depth to 1, and random state I'm changing to 42 or 23, whatever. And then I rerun it. The beauty of MLflow is when once we run it again, you see that a new run ID is created and we are able to, again, if we go to MLflow and we go to experiments, you'll see in 1708 the experiment, there is a second run already created 24 seconds ago. And you now exactly know what was used for this accuracy, F1 score, precision, what max depth. So you're able to compare all the things. Suppose you decide that this is the best model. You also know where the pickle file is. So you can deploy that model. So every detail of it has got saved. Also what I can do now is, because I have all the runs in the same data, I can select them and compare them. So now you know out of these two runs, orderly wolf and ambitious boar, you know which model is better. You know accuracy is better here in boar, F1 score is better, precision is better here. So which model is better for you? You can then decide here. Here you can look at graphs also. Here it is showing that for the two runs, the accuracy was 0.86 and for ambitious boar, it was 0.98, right? 984. So everything, all the plots are also self-made here and we are comparing them. I want all of you to run another set of experiments where you are playing with decision tree classifier for the same data set. So here we were running the random forest classifier. Can you create another experiment I've shown here for decision tree classifier? So what you are doing as a data scientist, you're playing with or doing trial and error with different models. First we tried with random forest. Now I want all of you to try out with decision tree. And then if we run this, you'll find that this experiment will also get logged into our data in MLflow. So here you see MLOps, DT MLOps. So today only we created this 15 seconds ago. And now it is tracking all the experiments of decision tree classifier. We can also select these two. And then here, suppose I select this. Here I select also all the experiments. Once I select two experiments, all their runs are shown here. I can now compare all of them also. So you exactly know that here we are comparing the three runs and we can see which experiment is performing better. Comparing three runs, so you can see three runs are being compared. We know that this is the one with decision tree classifier because it has been notified with that. And then we see that it has a lower accuracy than the best model. So this is how you can compare different model runs. This is the syntax which goes. First, we have to start with the experiment that we want to name the run with. So here we are logging the model with MLflow. So before that, if you see here, we have imported MLflow. And once MLflow is set up, and then we say MLflow.set experiment, it is logging, it understands with this function that it needs to log all the experiments under this, all the runs under this experiment name. So if you see here, this is the experiment name which is created, MLOps hard case. All the runs we make with this set experiment, it will start logging inside that. Now, Once this is done, we start the run. After the run is done, it will save the parameters. So if there are three parameters which it is saving, you can see, and these three parameters it is getting from here. We are passing these parameters. So what it is doing, it is saving these three parameters under log underscore param. So MLflow dot log underscore param. Then three metrics that we are logging for each run is precision, F1 score, and accuracy. That also we are calculating here. And then we have said that you log that metric. So from this it understands these are metrics. It is not parameters. Now, in order to save all the pickle files, in order to save the model, we are using MLflow.sklearn.log model. Model, we are passing a name of the model, random forest classifier. You can pass anything. And once this is done, it saves all the model artifacts under this model name. And once this is done, then we have print model logged with MLflow run ID accuracy. We are just printing it. And this is the run ID under which MLflow has saved the model. And yeah, so this is how we are getting and everything is logged here. You can see here. So I'll move forward now. I'm giving you one challenge, and the challenge run the dataset with XGBoost and log the model with MLflow. I'm giving you a hint. You will have to pip install XGBoost in order to run XGBoost in your local system. And I want you to start with a new experiment. So apart from, random forest decision tree, I want you to now, suppose I change this here, random forest decision tree. I want you to run for XGBoost also. How many of you will try it? So XGBoost is another algorithm which is used for machine learning. In the run of Google Colab, I'd used boosting there, but it did not yield good result. But I want all of you to run it today and let me know. Pip install XGBoost. I can use Copilot here also. Create an XGBoost model for the dataset. So it is giving it the same format which we require. So it is intelligent enough to understand that we want the same format. So it has created that. We'll just copy it. We'll paste it here. Import XGBoost as XGB. Then we are calling the model with these parameters. We're fitting the model. We are predicting from the model, and then we are calculating the scores, metrics. We are logging the parameters, logging the metrics, and then we are running this. So once we run this, let's see what name it has given, XGBoost classifier. Let's go through the MLflow, refresh it. I can't see XGBoost classifier. It is saying it has been logged. Let's check it. Here it is 1708 XGBoost. One run has been done. And if you see, the accuracy is not very high. So I think we can avoid with this model. So now what I am trying to show you all is, I was trying to see whether I can extract from the MLflow, if you see there is a run ID created. Similarly, there are experiment IDs created. Can we extract that? So that is what I was trying to run here. So what we are doing here is, so here model path. So what basically I'm doing now is, all of you please pay attention. I'm now saying that, okay, this is my folder where I am saving all my experiments. You extract for this experiment name the latest experiment done, get experiment by name. So from experiments, we are getting the experiment ID. From that experiment ID, I'm extracting, if you see, I'm loading that model and I want to rerun it. So here it is giving me an error that this path does not exist. Which path? The path where I am now loading the model. So this is the model where I am loading the model. It has a run ID and then there is a scaled KNN model. So the error which is coming out is this URL does not exist. So now I am giving you all a task. so that I understand you are all understanding the folder structure. I want you can use GenAI Copilot for it. What you need to do is debug this, use whatever experiment name you are using in your local machine and extract that model by using the experiment ID. Okay, using the experiment ID, extract that model and then run that model directly with your X test. So run it again, give the input of X test to that model and it should predict Y predicted and Y test. It should print that. So here path is not correct. So you are saying that you are logging the model with the name of XGBoost classifier. So if you see here, I have changed that, but still I'm getting an error. Key error is sklearn. It is giving me another error now. So I want all of you to debug this yourself. Why this error? So again, you can model does not have the sklearn flavor. Why? Because XGBoost does not use sklearn. XGBoost does not use sklearn. It's on its own. So let's see whether it understands that or not. Yes. So it is saying that this does not require sklearn. So now if I run this, beautiful. So it is running fine now. So what we have done basically, again I'm repeating, using experiment ID, we are extracting and running the model. Now you all can understand in the cycle of our year, we have done what? Let me draw this. We have first created our model, then we have logged that model into MLflow. And now suppose after 2 weeks, you want to test one of the model which you have created on and logged it on MLflow. What you are doing now is you can just use the experiment ID and you can run the model, run the trained model. So what is the benefit for you all? You don't need to worry about where the pickle file is, what all artifacts are required in order to run the model. Everything is taken care by MLflow. By just giving the experiment ID, it gets all the artifacts which is required to run the model. And this we also saw here. So suppose XGBoost, this is the run made. This is the experiment ID which it will extract. And the artifacts related to this is available here. So it exactly knows where is the ML file, where is the pickle file which is required or XGB file which is required to run this model. It knows the path for it. It is you taking that and running the model. So now if you see you are able to successfully inference the model by just calling the experiment ID and then once calling out the experiment ID, you are loading your model here and then you are using that model to predict. How many of you are understanding what I'm explaining? So as I explained with this schematic, is this clear to all of you? That first we created the model or we logged the model with MLflow. Now I'm using experiment ID. In this code, if you see, I'm getting the experiment ID by giving the experiment name. In this, the latest experiment ID, experiment, which has been done, it will extract that experiment ID and then it will load that model using that experiment ID and it will run the model.